Today we're going to look at applying linear graphs. So a constant rate of change of one variable compared to another means that the relationship between those two variables is linear. You'll get a line, a straight line, if you plotted the two variables against each other, and you would also get, if you were to make a rule of that graph, you would get a rule of the form y equals mx plus c, something that looks like that. So when we are applying linear graphs, when we're creating our own linear graphs and applying them to an everyday situation, we can choose letters to replace x and y to make meaning from that graph, to make meaning from that rule. So we could choose, if volume was involved, we could choose v to replace volume. If time was in our relationship, part of our relationship, we could use t to replace time. So in order for you to apply linear graphs, make a table of values that you can then that can allow you then to help you find a rule between those. So if we have a table of values here that link v, volume, in litres and t, time, in hours, it could be a 200 litre container that's leaking water. So after 1 hour it's leaked 25 litres out, after another hour another 25 litres, after another hour another 25 litres. We can then use the techniques that we know from working out the values for m and working out the values for c to actually get a rule out of our table. So we can see that for every hour, the amount, the V value here reduces by 25 litres, minus 25, minus 25, minus 25. So our value for M is going to be minus 25. Our value for C will be our value when our time here is 0. So our value when our time here is 0 is going to be 200. So C is going to be 200. So we've replaced Y with V. So these would be our Y values on our Y axis, would be these values here. M we've said is minus 25, negative 25, because we're reducing the value of V 25 litres each time. Our x values are going to be t, so 0, 1, 2, 3, they're going to be our x values here, t, and our c here is going to be 200. Our first example, we've got a hiker walking at a constant rate of 4 kilometres per hour. We've got a constant rate of change. That means the velocity is constant, he's increasing his distance the same amount every hour. So 4 kilometres every hour, he's travelling 4 kilometres every hour. So our first part, we need to draw a table of values. Then we need to draw a graph using that table, write a rule for our graph that links d with t, a relationship between our two variables, distance and time. Then we need to use our rule to work out make some sample calculations and work out some extra additional information. So here we need to use our rule to find the distance walked in 2.5 hours, and here we need to find the time to travel 8 kilometres. So we can create a table of values. If he starts at 0 time, increases every hour he's going to go another 4 kilometres. So our distance is going to add 4, add 4, add 4, add 4. So after 1 hour he's travelled 4 kilometres, after 2 hours he's done 8 kilometres, 3 hours he's done 12 kilometres. That's the definition of speed. Speed is the amount of distance that's taken with time. So every hour he's travelled an additional 4 kilometres. We can graph those values on a graph and obtain a linear graph. You can see that it is a nice straight line. So it is a linear relationship. We know we can find the rule for it. So to work out the rule, to find the rule for part C, write a rule linking D with T. Our distance here is on the y-axis and our time's on the x-axis. And every hour we've increased by 4. So our D has increased by 4, increased by 4, increased by 4, increased by 4. So our M value is going to be 4. So our Y is going to be D, Our m is going to be 4. Our x is t. These are our x values here, and our y values are t. Now our c value here is the distance when the time is 0, and the distance is 0 at that point. We're starting at point 0. So our rule is going to be d equals 4t. Now we can just double check that that's fine and go to a point in our graph, go to say time equals 3. So 4 times 3 is 12, and we see that our distance is in fact 12. So we know our rule at least works for that one point. Now for our question, use our rule to find the distance travelled for 2.5 hours of walking. So our time is 2.5 hours and we want to find the distance. So we write our rule, substitute in the value we know. We know that time is 2.5 and we get 4 times 2.5, which is 10. So that means 10 kilometres is travelled in 2.5 hours. Now for our last part, we have a look at, we want to find the time taken to travel travel 8 kilometres. So we substitute in our distance of 8 kilometres there, and we want to find t. So we can divide both sides by 4. Divide both sides by 4, we'll have 4t divided by 4, which is just our t left over, and 8 divided by 4 is 2. So the time taken is 2 hours. 8 kilometres takes 2 hours to travel. Our last example, here we've got a volume of water in a dish that starts out being 300 millilitres. The water evaporates, so the water is leaving the dish, and the volume decreases by 50 mils per hour, 50 millilitres each hour for 6 hours. So we're asked to draw a table of values once again and draw a graph once again. Also, we need to find a rule that links our volume with time. We need to use a rule to find the volume of water in the dish after 4.2 hours, and use the rule to find the time taken to reach 75 millilitres in the dish. So we can draw our table of values. Our initial value at 0 time when we start is 300 millilitres. I've chosen T to represent time and V, a capital V, to represent volume. So it says that every hour up to 6 hours. So I've chosen up to 6 for the values that we've got there for time. It decreases every hour by 50 millilitres. So if we start at 300, it will go to 250 in the next hour, then 50 mil less, 50 mil less, 50 mil less, 50 mil less, and 50 mil less. So we can then graph those values on a graph with V volume on the y-axis here and time in hours on the x-axis. So you can see our initial start is 300 millilitres. After 1 hour, we've got 250. After 2 hours, 200 millilitres, etc. That's what we've graphed. So for part C, to write a rule that links volume with time, our V is going to be, it's our Y values, so Y will be V, and our T, our time will be X values, so X will be T. Now for our gradient, M is going to be how much our volume decreases by each time, or how much our volume changes by each hour, each one point on our axis here, our x-axis, our time. So we're reducing by 50, minus 50, minus 50. So our gradient M is going to be minus 50. That is going to be, that's going to be our M there. Our C value is going to be the y-axis value when time is 0, when the x-axis value is 0. So at that point it's 300 millilitres. So our C value is 300. So this is our rule, V equals negative 50t plus 300. D, we need to use our rule to find the volume of water in the dish after 4.2 hours. So we know the time is 4.2, and we can substitute that into our rule. Our rule V equals minus 50t plus 300. We can substitute in 4.2, so that will be negative 50 times 4.2 plus 300. Negative 50 times 4.2 plus 300, and that's equal to 90. So 90 millilitres will remain after 4.2 hours. For E, we're asked to find the time for time taken for the volume to reach 75 millilitres. So our volume is 75 millilitres. Our time, we're trying to find out. So we need to subtract 300 from both sides to remove this 300 here, and subtracting 300 from this side will remove the 300. Subtracting 300 from this side gets negative 225. So we've got negative 225 equals negative 50t. So we can divide both sides by negative 50, divide both sides by negative 50, and that will yield just t on this side, and negative 225 divided by negative 50 is going to be 4.5. So our time is going to be 4.5. So 75 millilitres remains after 4.5 hours.